Hello guys and hello Mas Rezi. So today I will present about my group presentation about the final exam to introduction to data science. Let me introduce our group. My name is Melvin Syafandika. There's also Audrey Fisya Lauren Andisea, and then Rehan Bihaki Gunawan and Salam Octavianus. Let's begin to our paper and also our presentation about the final exam of introduction to data science. So first, for the chapter one, I will present about the introductions. So what is the background analysis of our using clustering in data science? It's about the data sets about the airports and the flights during the COVID-19 pandemics before and after. So the COVID-19 pandemic has been causing a significant impact on a very aspect of living. The pandemic has also caused many shifts in the industry performance, which can be described as dramatic change. The aviation industry is a great example of experienced dramatic change. The COVID-19 pandemic has been leading the aviation industry to the widespread disruptions and a reduction in air travel demands. So many airlines have not had no choice but to perform adaptive measures by reducing their schedules or suspending their operations temporarily due to travel restrictions and quarantine measures implemented by governments around the world. So as a result, the decrease in demand for air travels, many airlines have been inevitably faced by financial challenges and have had to lay off the full of employees, seek government bailouts, and restructure their operations. Airports and other aviation-related business have also been impacted by the decline in travel, which eventually lead to job losses and financial difficulties. So, in addition to the economic impacts in the industrial world, the pandemic has also led to the change in the way that air travel is conducted. So the changes can be seen from the increased cleaning schedule and sanitation measures, the policy implementation of mandatory face mask, and the introduction of rapid testing and vaccination requirement for travelers. So our objective to do the analysis have the objective in this paper and also the presentation. So the first one is to understand the impact of COVID-19 pandemic on the number of flights. And the second one is to identify any trends or patterns in number of flights before and after the pandemic. And the third one is clustering the number of efficient flight based on the data set that Mas Rezi was given in our lecture. And then what we will do actually, we will do the two analysis using two clustering. The first one is the k-means clustering, and the second one is the principal component analysis or PCA. So at the end of this paper presentation and analysis, we will conclude based on our clustering analysis using k-means and PCA, and then we interpret it to the analysis and provide a data plot on it. So we will also provide recommendations regarding to the impact of COVID-19 on number of aviation flights. So that's it for the introduction of our final exam, also our final project.
Good evening, Mr. Renzi. So in this presentation, I will be doing explanation about clustering. So the agenda for this presentation is to know what is clustering, to know what is k-means clustering, also to know what is principal component analysis clustering. So what is clustering? The process of clustering involves grouping a population or data point into a number of groups so that the data points of each group are more similar to one another. It is unsupervised learning technique and is typically used as a method to identify the groups that are inherent in set of instances. So how do it works? By applying clustering algorithm to the data. And the objective of clustering is to find the strict groups or cluster within a data set. Next is k-means clustering. K-means clustering is a type of unsupervised learning which is used when you have unlabeled data. K-means clustering use centroid, K different randomly initiated point in a data and assign every data point to the nearest centroid. And the objective of K-means is to grouping the data set where the group data is based on the data that has relationship to one another. So this is the example of K-means clustering. And as you can see here, the data set divided by three colors, the green one, the blue one, and the black one, which means that they have similarity to one another. Next, principal component analysis. It is one of the dimension reduction method in machine learning. PCA will choose variables that are able to explain most of the variability of the data. PCA reduces dimension by forming new variables called principal components. So how do it works? By transforming a large set of variables into a smaller one that still contains most of the information in the large set. The objective is to help to find latent feature among all the data and to make it easier to visualize data and faster training. So this is an example of PCA clustering.
Halo Mas Rezi, I am Salom Octavianus. I will be explaining k-means clustering analysis. And the first one, we are talking about the impact of COVID-19. So here we see the differences between the average number of flights before and after the COVID-19 pandemic. And the graph shows a fluctuation in the number of flights over a certain period of time. So the trend appears to be generally downward, with a slight increase from 2017 to 2018, followed by a significant decrease from 2019 onwards. The values steadily decrease as the time progresses, with a notable drop in the number of flights compared to the previous period. This could be due to the variety of factors, such as the impact of COVID-19 on the aviation industry. Then we will use the data from 2017 to 2019 as the data before COVID and 2020, and to 2022 as the data after COVID, because the first case of COVID-19 in Indonesia was detected on March 2, 2020. And the next graph compares the number of flights between the two time periods, 2017 to 2019 and 2020 to 2022. The data shows that the number of flights during the 2017 to 2019 period was significantly higher than the number of flights during the 2020 to 2022 period. The difference between the two is approximately 207 flights. This suggests that there has been a significantly drop in the number of flights between the two time periods. Here is the exploratory data analysis. And the next one, we need to determine optimum K. So determining the optimal number of clusters, or K, is the first and important step in using the k-mean clustering algorithm, as the value of K can affect the results of the clustering. In general, a smaller value of K will result in more similar points being grouped together in the same cluster, while a larger value of K will result in more dissimilar points being placed in separate clusters. The appropriate value of K for a given data set will depend on the inherent structure of the data and the specific goal of the analysis. Before conducting a cluster analysis, it is necessary to determine the optimal number of clusters to use. In clustering, the goal is typically to minimize the sum of the distances between observations within each clusters, also known as the within cluster sum of squares. There are several methods that can be used to identify the optimal number of clusters, including the elbow method, silhouette method, and gap statistic. To determine the final number of clusters, it is common to use majority voting to choose the number of clusters that is most frequently recommended by the different methods. So the first method is elbow method. So choosing the number of clusters using the elbow method is arbitrary. The rule of thumb is we choose the number of clusters in the area of bend of an elbow, so where the graph is total within the sum of squares and start to stagnate with the increase of the number of clusters. So using the elbow method, we know that the 3 clusters is good enough since there is no significant decline in total within clusters sum of squares on higher number of clusters. And the second method is silhouette method. So the silhouette method is a technique for evaluating the quality of a clustering solution by measuring the degree to which its observation is similar to the other observations within the same clusters, compared to the observation in other clusters. To calculate the silhouette coefficient for an observation, the method first measures the mean intra-cluster distance, which is the average distance between the observation and all other observations in the same cluster. The method then measures the mean nearest cluster distance, which is the average distance between the observation and all observation in the nearest cluster. The silhouette score for an observation is then calculated as the difference between the mean nearest cluster distance and the mean intra-cluster distance, divided by the larger of the two, and the silhouette scores for all observation in the clustering solution are then averaged to obtain the overall silhouette score for the solution. To determine the optimal number of clusters using the silhouette method, you can choose the number of clusters that results in the highest overall silhouette score, and this is typically identified as the peak in silhouette score plot, which is a graph that plots the silhouette score for each number of clusters. Based on silhouette method, the number of clusters with maximum score is considered as the optimum K clusters. The graph shows that the optimum number of clusters is 2. Next method is gap statistic method. So the gap statistic is a technique where evaluating the optimal number of clusters in a data set by comparing the total within cluster variation for different values of k, where k is the number of clusters, with their expected values under a null reference distribution of the data. The null reference distribution is a hypothetical distribution of the data that is generated using a Monte Carlo sampling procedure. To calculate the gap statistic for a given value of k, the method first calculates the total within cluster variation for the clustering solution with k clusters. This is the sum of the within cluster sum of squares for each cluster in the solution. The method then generates a set of null reference distribution and calculates the total within cluster variation for each distribution. The gap statistic is then calculated as the difference between the total within cluster variation for the original data and the average total within cluster variation for the null reference distributions, normalized by the standard deviation of the null reference distribution. To determine the optimal number of clusters using the gap statistic, you can choose the value of k that maximizes the gap statistic. This is typically identified as the elbow in the gap of statistic plot, which is a graph that plots the gap statistic for each value of k. Based on the gap statistic method, the optimal k is 5. 3 out of 3 methods for finding the optimal number of clusters produce different results. So we need to decide to use the median value of the 3 methods, which is 3. So this is the result of making k-means clustering. The ratio between the sum of squares distance between clusters to the total sum of squares is 94.6%, meaning that most of the sum squares distance comes from the distance between clusters. Thus, we can conclude that our data is properly clustered since the observations in the same cluster have a little distance or variations. The number of members on each cluster is not equally distributed. So the last one is interpretation or cluster profiling. With this table, we can interpret the 3 different clusters. So cluster 1 consists mostly of airports, which has high number of flights. And cluster 2 consists mostly of airports, which has a low number of flights. And the third cluster consists mostly of airports which has a number of flights in the middle of both. So this is the visualization of cluster plot. This is the end of the k-means clustering analysis. Thank you for your attention, Ms. Masrezi.
Hello everyone. Hello Mas Rezi. My name is Rian Begi Punawan, and now I'm going to explain the principal component analysis. What is principal component analysis? PCA is a technique for reducing the dimensionality of the data and increasing the interpretability, but at the same time minimizing information loss. First, we check the covariance metric of the data. The value of the variance and covariance are affected by the scale of the data. The higher the scale, the higher the value of variance covariance will be. Here we got high variance, so what we need to do is scaling. Scaling need to be done before performing PCA so that the variable have scales that are not too different from each other. After we perform the scaling, we still got high variance. This can happen because of several possibilities, including outliers and multicollinearity. The next one, we're going to perform dimensionality reduction. Here we will make PCA from the Bandara datasets. We will see the eigenvalue and the percentage of variance explained by each dimension. The eigenvalues measure the amount of variation retained by each principal component. Eigenvalues are large for the first PC and small for the subsequent PC. Here is the first PC correspond to the direction with the maximum amount of variation in the datasets. As we can see here, dimension 1 capture 96.4% of variance, while dimension 2 capture 2.6%. In cumulative, dimension 1 and 2 capture almost 99% of the variance, which means by reducing or using only 2 dimensions, we have obtained almost 99% of information from the data. This also means that dimension 1 capture almost all the information contained in the original 5 features in the data. We can extract the values of PC1 to PC3 from all of the observation and put it into a new data frame. This data frame can later be analyzed using supervised learning classification technique or other purpose. This is the new data frame. So the next one is individual observation map. Cos2 or square cosine value show the importance of principal component for a given observation. The value of cos2 can help find the components that are important to interpret observation. The individual observation map shows where each of the observation is positioned in terms of PC1 and PC2. Using only first two PC, we can see that there are a lot of outliers in our data that have high cos2 in the PC1. This is the visualization, and this is PC1, PC2. The ellipse represent the standard deviation. So the Cengkareng, Ngurah Rai, and Juanda is outside the ellipse, which means that this is the outlier of the data. Next one is variable vector map. The distance between variable and the origin measures the quality of the variable on the vector map. The color indicates the contribution of each variable. The contribution of variable in accounting for variability in a given principal component are expressed in the percentage. Variables that are correlated with PC1 and PC2 are the most important in explaining the variability in the datasets. We can check the quality of representation of cos2 of each variable. A high cos2 indicates a good representation of the variable on the principal component. In this case, the variable is positioned close to the circumference of the correlation circle. A low cos2 indicates that the variable is not perfectly represented by the PC. In this case, the variable is close to the center of the circle. As we can see here, the black one is the 2019, which is highly contributed to the PC2, and the yellow, the 2020, which has the highest contribution toward PC1. Next one, clustering with PCA. PCA can be also integrated with the result of k-means to help visualize the data in a fewer dimension than the original. One common application of PCA is clustering, where the principal component derived from PCA can be used as input into clustering algorithm. This can be particularly useful when the original variable in the data are highly correlated, as PCA can help to decorrelate the variable and make it easier to identify distinct cluster in the data. In the above visualization, our cluster look like intersecting each other because we don't have enough dimension to represent them. So you can see in the cluster 3, which is the blue one, intersect the green and the red, and the green also intersect with the red one. So here we make one more visualization, which is three-dimensional plot to help visualize the cluster. That's all for me. The conclusion and suggestion will be delivered by Malvin. Thank you.
So then we'll get to do our closing final project or final presentation of our exams. So this is the chapter 5 about the conclusion, suggestion, and recommendation. So we can conclude based on our analysis with two types of clustering using k-means and PCA we can draw some conclusion about our data set based on the previous cluster and principal component analysis. So we can see the data in here. So is it that true the COVID-19 has an impact on the aviation industry? As we can see from the graph above, there is a significant change in the number of flights, and this is happening because of COVID-19 pandemics. So we can see from the data from 2017 to 2020 is giving a significant changes in the number of flights of aviation flights. Then also we can separate our data into at least three clusters based on all the numerical features with more than 94.6% the total sum of squares coming from distant observation between clusters. Then we can reduce our dimension from 5 features into just 2 dimensions and still retain more than 99% of the variance using PCA. The dimensionality deduction can be useful if we apply the new PCA information learning application. So however, at the end, as we have seen, the dimensionality deduction is not enough for us to visualize the clustering of our data, indicated by overlapping of cluster. If we only use the first 2 dimensions, perhaps the result from the gap statistic method is true, that there is only one big cluster. So based on our conclusion by the two analysis using K-means and PCA, we also suggest and recommend about our project. So to mitigate the impact of the panic on the fashion industry, some measures that have been taken included. Actually, there's 5 implication of policy that we should that our group recommend and suggest. So the first one is the government financial assistance to airlines. So it talks about the many governments have provided financial assistance to their domestic airline to help them weather the economic downturn caused by the pandemic. And the second one is a waiving of fees and charges. So some airports and air navigation service providers have waived fees and charge to help airlines reduce their operating costs. Then the third one is temporary suspension of operation. Some airlines have temporarily suspended operation or significantly reduced their flight schedule in response to the decrease in demand for air travel. And the fourth one is the implementation of safety measures. So airlines have implemented enhanced cleaning and disinfection protocols, as well as a mandatory face mask policy and other measures to reduce the transmission of the virus. And the fifth one is the introduction of flexible booking policies. So many airlines have introduced more flexible booking policies, such as the ability to change cancel flights without penalty to help travelers feel more comfortable booking flights during the pandemic. So overall, our conclusion and suggestion and recommendation is the impact of COVID-19 pandemic on aviation has been significant, but measures such as a government assistance and the implementation of safety measures have helped to mitigate some of the negative effects. So that's all from our group projects. Is about the aviation of number 5 data sets, and also we also do the paper analysis and presentation. So that's all. Thank you, Mas Rezi. Thank you all.